Now that we're calculating the accurate balance of a wallet, let's make sure that this information is accessible. We're going to add a new API request to the Express server that includes this balance. So let's head to the main index.js file. Overall, we're going to call this new API request the wallet info. Now, wallet balance might have been a better and more succinct name. However, we're also going to include the wallet's public address in this request as well. So this not only gives the wallet owner visibility of their public address, but it's going to allow other nodes to discover the wallet's public address so that way it can receive transactions. So you essentially want this endpoint so that way other people can know your public address and send you money. All right, so let's make a new GET request. And this one is going to be after our mine transactions request. And this is going to be called API/wallet-info. And then we have our rec and res parameter. Nice. Overall, we want this GET request to return both the address and the balance. So we're going to include both of those in a res.json object. It's called res.json. And first we're going to have the address, which is the local wallet.public key. Cool. And now we want to include a balance key as well. Let's place the address on its own line, so that way the balance can come on its own line. And the balance we're going to calculate by using the wallet.calculateBalance function. So that way it always accurately reflects the blockchain history. To calculate the balance, we need to pass in the chain, which is the local blockchain.chain. And the address is the wallet.public key that we're calculating for. All right, nice. So that completes the address and balance fields for our wallet info request. However, notice that we are accessing wallet.public key twice, and moreover, we're both setting those as values for an address key, so we might as well make an address constant in this. That is the wallet.public key itself. And now this can be used implicitly without explicitly setting it to wallet.public key, and in here as well. All right, that's looking pretty clean. So that wraps up the new API wallet info request. Let's start up the application and test it out. In the command line, fire npm run dev, so feel free to have the test runner going on in the background. But in another tab or another window, fire npm run dev until you see that nice familiar message of listening at localhost 3000. You can either go to the browser or Postman, but let's go to the browser since we haven't done that in a while. And let's go to localhost 3000/API/wallet-info. And as we do this, now mine is kind of zoomed in, but here we have the address and the balance just as expected. All right, cool. So this is really getting in the way, but you can see that we do have the address and the balance there. Nice. Now the balance is currently a balance of 1,000, which is the starting balance. And then this address is actually a string of 130 hexadecimal characters. Cool. So this was a quick bit of functionality to add, but it's actually a crucial one, considering that when multiple wallets interact, they're going to need to find a way to interact with each other by discovering each other's addresses. So this actually brings us to the last part of the blockchain backend that we're going to add, which is chain validation for blocks that consist of transaction data. Now, this is arguably the most crucial part of the project in making the blockchain secure when it comes to powering a cryptocurrency. At this point, we have some validation going on to make sure that chains aren't malformed. However, this validation is generic. It checks that the Genesis block looks good and makes sure that all the last hash references are actually referencing the last hash, and then it makes sure that all the generated hashes are good as well. But it doesn't do any special validation on the data field itself, which is where all the transactional information for a block lies. Conceivably, an attacker could still send a chain that consists of a bunch of valid hashes. But then that chain could be comprised of data that doesn't follow the rules we set up for the cryptocurrency. Even worse, it could consist of transaction data that doesn't follow the cryptocurrency format. Therefore, we need to validate all chains broadcasted on the network on a deeper level to make sure that the transactional data looks good. In the next one, we're going to review the rules of the cryptocurrency when it comes to the generation of transactions. And then we'll actually enforce those rules through extra validation in our blockchain and cryptocurrency application.